Now sometimes the difference of squares may be hidden in some other complex polynomial. So if that polynomial doesn't seem like something special, then we always start with taking the GCF, the common factor, the greatest common factor, out. And then we are going to check if there's something special like the difference of squares or maybe a quadratic expression or something like that. Now let's see some examples. Now in this example we have 9x cubed minus 4x. Well, this doesn't seem like a difference of squares, but actually there is a difference of squares in this expression. Just that we need to factor the polynomials and then take the greatest common factor out. Let's see. Now here for 9x cubed we have 3 times x times x times x. And for 4x we have 2 times x. Now, if we find the common factors, we see that we only have x in common. So what we're going to write here is x outside the brackets, and inside I have 9, 3 times 3, and x squared, which is x times x, minus 2 times 2 is 4. Now we have the difference of squares, so we will write like x times 3x squared minus 2 squared, because 3 squared is 9 and x squared is x squared. So the factored form of this expression is x times. Instead of these difference of squares, we write the factored form of it, which is 3x minus 2, 3x plus 2. Okay, in this example we have 2p cubed minus 162p. Now, this is 2 times p times p times p, and this is, well, it's hard to factor. It is 2 times 3 times 3 times 3 times 3 times p. Now, what is common? 2 is common, and p is common. So we can say this expression is equal to, in 2p brackets, we have p squared minus 3 to the power 4, which is 81. Now we can write this, let's write it there down. We can write this as 2p times p squared minus 9 squared. Now you see we have the difference of squares right away, right here. So let's go on. This is 2p, and instead of p squared minus 9 squared, I'm going to write p minus 9, p plus 9. Okay, now is your turn. Please factor these expressions, solve, and show me.